Guys, Mr. B here, and this video we're going to be going through chapter 8.1 on molecular compounds. So this is the first chapter in our second half of the class, and in this chapter we're going to be looking at how compounds are formed with molecular bonds. So the last chapter we were dealing with ionic compounds, which is where you had a positive ion and a negative ion, and those two things would come together sort of like magnets, right? You got opposite charges, they would attract each other. And in this chapter, we're going to be looking at bonding where you don't have charges, but instead the bonds are made by sharing electrons. Okay, so we'll go into depth on what that means. It's a little bit different from what we think of the word sharing, right? Where you give someone something that's yours and that's, you're sharing. Not quite the same. Okay, in chemistry, sharing is different from like, well, it was mine and now you have it. That's giving. Okay, that's transferring. Where it was mine and now you have it. That's transferring. Even though it's yours, you might get it back and you're sharing. It's not really sharing in chemistry. So anyway, so let's talk about molecular compounds and what those are in general before we, of course, will dive deeper into bonding later in this chapter. All right, so first off, we're going to talk about some properties of molecular compounds and molecules. Okay, so we're going to look at melting points and boiling points and how they're different from ionic compounds. So first off, understand that in nature, a lot of times we are going to find matter that takes all kinds of forms, whether it be solids or liquids or gases. And a lot of the compounds that we're going to deal with in this chapter are not solids. Okay, they're usually gases or liquids at room temperature. Doesn't mean, of course, they can't be solid. They are definitely solid in some cases. But the noble gases are a particular one, which are molecular, and they're gases at room temperature. So these are the elements like helium, neon, argon, krypton, radon. These elements are things that we consider monatomic. So what that means, it means mono, okay, which means one or single, and atomic, which means atom. So if you were to find a noble gas in real life, you would find individual atoms, okay, of these elements floating around. Like if you blew up a balloon with helium gas, there'd be individual helium atoms floating around inside that balloon, but not all elements and compounds exist like that, okay, in real life. So these are actually very rare in the fact that they exist as single atoms. Most compounds, again, are a little bit different like this. So ionic compounds basically are usually two ions that are bonded together by transferring electrons from one ion to another ion. But with molecular compounds, like, the noble gases don't really make molecular compounds, but with molecular compounds or covalent compounds, is another word you're going to hear me say, and those are interchangeable. They mean the same thing. Electrons are shared between atoms. So sharing, again, means that instead of one electron leaves and goes to another atom, it actually sits in between both atoms and essentially exists for both of them. Okay, so imagine you have two atoms and there's electrons in the middle, and those electrons are part of this atom here, and they're also part of this atom over here. Okay, so they're connected to both atoms at the same time. That's what we mean by sharing. This is what we call a covalent bond or a molecular bond. Okay, again, molecular and covalent are essentially the same thing. Okay, so anything that is bonded together with covalent or molecular bonds we call a molecule. Air, for example, contains oxygen, which is a molecule because there are two oxygen atoms that are bonded together by covalent bonds. Water is a molecule. It is an oxygen atom and two hydrogen atoms, which are bonded together by covalent bonds. So we're going to be dealing with molecules in this chapter, and the key thing to note in this chapter specifically is the types of elements we're going to be dealing with. Okay, in the previous chapter with ionic compounds, we were dealing with metals and nonmetals. But in this chapter, the elements we're going to be dealing with are nonmetals only. Okay, this is a very important thing to understand. Molecular compounds form between nonmetals only. We will not be dealing with metals in this chapter. So if you remember from the periodic table, all the elements that are to the right of the staircase are nonmetals, which there's not that many. The periodic table is majorly going to be metals. So previously with the noble gases, earlier on here in this chapter behind, we talked about how they are monatomic, okay, monoatomic, meaning they're single individual atoms. But a lot of elements in nature are diatomic. Okay, now the word diatomic means two atoms. Okay, di means two. So a diatomic molecule is a molecule that specifically consists of two atoms, and there are 7 primary elements that in nature, when you find them, they are diatomic, which means there's always 2 atoms of them bonded together. They don't exist as individual atoms. You know, I'm going to tell you right now, this is a really, really important piece of information that is going to come up a lot. Okay, I cannot stress this enough. A lot. So write this down, remember it. Okay, I call these elements the Brinkelhoffs. And I call them that because if you spell out the word Brinkelhoff, it will tell you what elements they are. So we have Br for bromine. In fact, you know what? I'm going to zoom in here just so we can actually see this better and make sure we don't miss this. So the 7 elements that exist in nature diatomically, meaning that when they're in nature, it will be 2 of them. Okay, you'll never just see a Br. It's always 2 Brs. So we have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Okay, this is why I call them the Brinkelhoffs. If you spell out bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, spell out Brinkelhoff. Okay, so these 7 elements, so we'll even say these 7 elements that are diatomic in nature. That means, again, that when you find them in nature, they will always be paired with another atom of themselves. Okay, always. So you'll never just find a bromine atom floating around. It'll be 2 bromine atoms, which makes a molecule. Okay, this is going to pop up a lot. So remember these. I'll remind you of them all the time in future videos. Trust me, you'll hear me say Brinkelhoff all the time. Okay, so, all right, anyway, moving on. So a compound composed of molecules is what we call a molecular compound, or again, a covalent compound is another way to name it. It's the same word for, a different word for the same thing. Water and carbon monoxide are molecular compounds. They are made of nonmetals that are bonded together by sharing electrons. Okay. So when it comes to molecular compounds and how their properties are different from ionic ones, typically, again, they're not solids at room temperature. Most of the time, they're liquids and gases. But also, they tend to have lower melting and boiling points than ionic compounds, which is the reason why, again, most of them are liquids or gases at room temperature. And that's primarily because their bonds are a little bit, not necessarily weaker, but they aren't so rigid, okay? And the fact that, they're not stuck in place. Ionic compounds are kind of stuck in place. You got all these ions that are, locked together. They can't really go anywhere, which makes them a solid. But molecular compounds can kind of move around more in terms of how their molecules are, which gives them the ability to be more liquid-like or fluid-like, okay? Either being liquid or gas. So if we take a look at this image here, we have table salt, which is sodium chloride. It's an ionic compound. And basically, if you were to look at the crystal structure or how the ions are arranged, you'll see that you've got a sodium ion, which is yellow, and a chloride ion, which is green. And this basically just kind of repeats itself over and over and over, and they kind of are all locked in place, okay, which is what makes it a solid. Whereas water molecules are each their own individual little molecule, and they kind of float around near each other. Okay, now they're slightly attracted to one another, but for the most part, they can kind of move around all over the place. They're not stuck in place. Which, makes them a fluid, makes them a liquid, and they can, they have more fluid-like properties. Here's another one, ethane, which is a component of natural gas as a molecular compound. It's a bunch of carbon and hydrogens. And again, their molecule looks like this. And then a propane gas or ethane gas would be a bunch of these molecules that are all kind of floating around nearby each other. Okay. So lots of different types of compounds here. Okay. Now, when we write out molecular compounds, we will write out a molecular formula or a chemical formula. We just call it a molecular formula because it's a formula for a molecular compound. So what is a molecular formula and what information does it provide? So molecular formulas are basically the chemical formulas for molecular compounds, just like ionic formulas would be the formula for an ionic compound. Now there's 2 things that a molecular formula or any chemical formula will always tell you. The first one is how many atoms are present in the molecule and what elements are present in the molecule. Okay, so it tells you how many of an element and what elements you have. So this is a chemical formula for ammonia, which is a component in a lot of fertilizers. And it has a chemical formula or molecular formula of NH3. So it's 1 nitrogen, 3 hydrogens. Okay, we're going to see molecular formulas written a lot. But there are other ways to represent molecular formulas. We can do so in a visual way. With a space-filling molecular model. This would be a computer-generated image. It's supposed to be three-dimensional to kind of show you what the model looks like. We can use a structural formula, which is two-dimensional, but it's a drawing two-dimensionally to show you what the molecule looks like. We can use a ball and stick molecular model, which a lot of times are built in person. So you might, have in a class a bunch of sticks that are like little balls and sticks, and you stick them together and you make a three-dimensional version of this molecule that you can, manipulate with your hands. Or lastly, we have a perspective drawing, which is essentially a two-dimensional way of drawing something that's three-dimensional. So these black kind of like triangle-looking things are representing the chemical bonds, and they're like representing the fact that they're coming like out of the paper at you rather than laying flat. Okay. Either way, we will primarily deal with molecular formulas and structural formulas. We will do some ball and stick molecular modeling in class, or you might watch a video of me doing some modeling, but the two main ways are molecular formulas and then drawing structural formulas. Okay, in this chapter, we're actually going to do quite a lot of drawing, so we'll learn more about that later in this chapter. All right, and then the last thing here to note is that there are lots and lots and lots and lots of molecular compounds. Even though, of course, you're only dealing with nonmetals, which there are not that many nonmetals on the periodic table, the arrangement that you can put them in is almost infinite. So you're going to find all kinds of molecular compounds that have the same elements in them, but they're just arranged in a different way, and therefore it's a new compound that has new chemical properties and behaves differently and is named something different and all this stuff, even though it might be the same three elements all the time, which is like carbon, oxygen, and hydrogen. Okay, so there's three molecular compounds shown here between basically these three elements. We have water, we have carbon dioxide, and then we have ethanol, which is drinking alcohol. It's the alcohol that you find in any kind of alcoholic beverage that we drink, whether it be beer, wine, any kind of hard liquor. Ethanol is the type of alcohol that is present. There are different types of alcohol too, by the way. Methanol, there's isopropanol, but ethanol is the only one that we can drink and it won't kill us, or at least not up front. So, all right, anyway, so that is it for this section, guys. Just a little bit of an intro. We're going to learn a lot more about this stuff in the coming sections. So, as always, if you have any questions, feel free to email me or reach out. And as always, just make sure you get those questions answered. All right, guys, I'm Mr. B. See you in the next one. Bye.